Hi guys, I hope you all are doing well. Today we are going to learn about inverse functions, which is very important and an easy topic. I am sure you will master it if you pay attention for a few minutes in this video. So let's start, okay? What do you mean by inverse function? What do you mean by inverse function? Let's say if you have a function, let's say if you have a function fx, if you have a function y equal to f of x, okay? Now if you take the image of this function, if you take the image of function fx with respect to the line y equal to x, with respect to wrt, with respect to the line y equal to x, with respect to the line y equal to x, then the image that you get will be f inverse x. So the image of fx with respect to the line y equal to x is f inverse of x, is f inverse of x. So okay guys, one thing that I want to clarify here is how do you write inverse function? How do you write inverse function? You write it as f power minus 1 x, f power minus 1 x. Now remember that f power minus 1 x is not 1 upon fx. It is not 1 upon fx. So this is a very common mistake which a lot of people do. If I have to write 1 upon fx, if I have to write 1 upon fx, I'll write it as f of x whole power minus 1, whole power minus 1. Okay, so always remember f power minus 1 x is f inverse x, is f inverse x. Very important, very important. Okay, anyway, so I said that the image of fx with respect to line y equal to x is f inverse x. The image of fx with respect to the line y equal to x is f inverse x, is f inverse of x. Okay, very important. So let's say you have, okay, let's draw a Cartesian plane here. Let's say this is your y-axis, this is your x-axis, and this is your origin. This is your origin. So let's draw a line y equal to x. Let's draw the line y equal to x. So let's say this line is y equal to x. This dotted line is y equal to x. Okay. Now let's say if you have a function, if you have a function like this, if you have a function like this. Okay. What will be the inverse function? What will be the inverse function? The inverse function will be image of the red graph with respect to the line y equal to x. So the image will look something like this. The image will look something like this. The image will look something like this. So if this is your, okay, I'm so sorry. If this is your f of x, if this is your f of x, then the green one is your f inverse x. Then the green one is f inverse x. Let's take one more example. Let's take one more example. Let's draw a Cartesian plane again. I'll draw it here. I'll draw it here. Let's say this is your y-axis, this is your x-axis, and this is your origin. This is your origin. Okay. Now guys, let's say you have to draw y equal to x line. Let's first draw y equal to x line. This is your y equal to x. Okay. Now let's say your fx looks like this. Your fx looks like this. Your fx look like this. So how will your f inverse look like? How will your f inverse look like? It will be an image. It will be an image. So it will look something like this. It will look something like this. Okay. So the diagrams are not drawn to the scale. There might be some error in drawing the diagram, but if you draw the graph of fx and f inverse of x on your Desmos or on your GeoGebra, you will realize that f inverse x is the image of fx with respect to line y equal to x, with respect to line y equal to x. I'll write it down. Okay. Now one thing that you should remember, or you should notice here is, if you observe this point, or if you observe this point, the graph of fx and f inverse x, are meeting, are intersecting on the line y equal to x. So this is the point of intersection for the first graph. This is the point of intersection for the second graph. If you observe, both the graphs are intersecting on the line y equal to fx. Both the graphs are intersecting on the line y equal to fx. So it is very important that you know it. Okay, now let's see algebraically what's happening. So you are taking image with respect to line y equal to x, with respect to line y equal to x, which means y will become x and x will become y. Y will become x, x will become y. So the question is how to find the inverse function, how to find the inverse function, how to find the inverse function, how to find inverse function. Very easy, guys. It's a two-step process. It's a two-step process. So step number one is swap x and y. Swap x and y. So wherever you see x, write it with y. Wherever you see y, write it with x. So swap x and y. And second step is make y as the subject. Make y as the subject. You have to make y as the subject. If you do these two steps, you will get the answer. I'll give you some examples. I'll give you some examples. Okay. Let's say you have y equal to x minus 1 upon 4. Y equal to x minus 1 upon 4. Let's say this is your function fx. This is your function fx. How to find inverse? How to find inverse? So first step number one is you replace x and y. I mean, you swap x and y. You replace y with x. You replace x with y. So this becomes x equal to y minus 1 divided by 4. Okay. Now you have to make y as the subject. You have to make y as the subject. So let's solve. Let's solve. So I mean, take 4 on the other side. So this becomes 4x equal to y minus 1. Shift minus 1 on the other side. So it becomes 4x plus 1 equal to y. Okay. So if you see y is the subject here, you can write this as y equal to 4x plus 1. You can write this as y equal to 4x plus 1. So this thing over here is your inverse function. This is your f inverse of x. This is your f inverse of x. Okay. So what do? You swap x and y and then you make y as the subject. If you observe, I told you here that when you take image with respect to y equal to x, y becomes x and x becomes y. Y becomes x and x becomes y. Which means that in inverse function, what happens? The domain becomes the range. The domain becomes the range. And the range becomes the domain. And the range becomes the domain. I'll give you a very good example. Let's say you have a function y equal to sine x. Y equal to sine x. Okay. What is the domain of this function? What is the domain of the function? The domain of sine x is all real. The domain of sine x is all real. In x, you can substitute any value. There is no restriction on x. What is the range? What is the range, guys? Range is minus 1 to 1. Range is minus 1 to 1. Your graph of sine x is restricted between minus 1 and 1. Your graph of sine x is restricted between minus 1 and 1. So this is the domain, this is the range. Now what is the inverse? Okay, this is your fx. This is your f of x. What is your f inverse of x? What is your f inverse of x, guys? F inverse of x becomes y equal to sine inverse of x. Y equal to sine inverse of x. So the inverse of sine x is sine inverse x, right? What is the domain of this function now? What will be the domain? The domain here will become the range. Okay. So the domain of f inverse x, the domain of f inverse of x will be nothing but range of fx. It will be nothing but range of fx. So the domain here becomes minus 1 to 1. So the domain here becomes minus 1 to 1. And what is the range? What is the range of f inverse x? So the range of f inverse of x, the range of f inverse of x will become the domain, will become the domain of fx. So the range here becomes all real. The range here becomes all real. So please remember, let's say you have f of x, you have f inverse of x. Okay. Let's say you have domain and you have range. So if the domain of fx, I'll make a table. And this will be an easier way for you to remember. Okay, let's say if the domain of fx, is a, and if the range of fx is b, then what is the domain of f inverse of x? So the domain of f inverse x will be b, and the range of f inverse of x will be a, So guys, in inverse function, y becomes x, x becomes y, which means domain becomes the range and range becomes the domain. Okay, I hope you understood. It's a very important concept. Now, one more important concept that you should remember is that the graph of fx and f inverse of x, intersect at y equal to x, Okay, so let's say, for example, you have a function y equal to ln x. You have a function y equal to ln x. Or let's hold on. Let me take an easier example. So it becomes easy for you to calculate. Let's say you have y equal to x square. The question is, find the intersection of fx and f inverse of x. So traditionally, what would you do? You will find the value of fx, which is given x square. Then you will find the value of f inverse of x, and then you will equate them or draw the graph and find the point of intersection, right? That's the traditional way. But the easier way could be, you just substitute x square and you equate it with x. Because fx and f inverse of x, fx and f inverse of x both intersect at y equal to x. So this is how you can equate and get the answer. For example, if you observe, we had a function here. We did a small example. This was the function y equal to x minus 1 upon 4 and y equal to 4x minus 1. The question is, find the point of intersection of fx and f inverse of x. The question here is, find where does fx and f inverse of x meet. You have to find this. So the traditional way is, you find fx, which is x minus 1 upon 4, and then you equate it with 4x plus 1. You solve it manually and get the answer, or you draw the graph of left hand side, draw the graph of right hand side, and find the point of intersection on your calculator. This is what one of the ways is to find the point of intersection. The other way, and the simpler way, is instead of you doing this, you simply substitute x minus 1 upon 4 equal to x. Okay, so we'll solve both of them. Okay, let's solve this first. So over here, I am substituting 4 on the other side. So what do you get? You get x minus 1 equal to 4 times 4x plus 1. So you get x minus 1 equal to 16x plus 4. So take it on the other side. Shift 16x on the left, shift minus 1 on the right. So you get x minus 16x equal to 1 plus 4. So minus 15x equal to 5. X equal to 5 upon minus 15. X equal to minus 1 by 3. So at x equal to minus 1 by 3, the graph meets. Okay. This is what I got when I equated fx with f inverse of x. Instead of doing that, you can simply equate fx or f inverse of x with x. So either you can do this, or you can do 4x plus 1 equal to x. Both are correct. So you either equate fx with x or you equate f inverse of x with x, you will get the same answer. You will get the same answer. So let's solve this. So you have x minus 1 equal to, I'm shifting 4 on the other side. So x minus 1 equal to 4x. Shift 4x towards the left, shift minus 1 towards the right. So this becomes x minus 4x equal to 1. So minus 3x equal to 1, x equal to minus 1 by 3, x equal to minus 1 by 3. So that's what you got here. That's what you got here. That's what you've got here. Now the third way, you substitute f inverse x as x. So let's solve it. Let's solve this. So you get shift x on the left, shift 1 on the right. So 4x minus x equal to minus 1, which means 3x equal to minus 1, which means x equal to minus 1 by 3, which means x equal to minus 1 by 3, and you have gotten the same answer. You have gotten the same answer. So the conclusion is, if you have to find the point of intersection of fx and f inverse of x, either you equate fx and f inverse x and solve it and then get your answer, or you can equate fx to x and solve it and then get the answer, or you can equate f inverse of x to x, solve it and get the answer. Okay, so very easy way to solve the intersection of fx and f inverse of x. I hope you understood. Now we'll do two more questions and then we'll call it off. Let's say y equal to x minus 1 and 2 minus x. Your question is to find the value of f inverse of x. Okay, so first step number 1 is you replace x and y. You swap x and y. I'm so sorry. So x equal to y minus 1 upon 2 minus y. Okay. Now second step is you have to make y as the subject. So I'm shifting this on the left. So x times 2 minus y equal to y minus 1. Okay. Let us solve this. 2x minus xy equal to y minus 1. Now let us collect the term of y's on one side and rest of the terms on the other side. So I'm shifting minus xy towards the right. I'm shifting minus 1 towards the left. So 2x plus 1 equal to xy plus y. Okay. Now from here take y common. So y times x plus 1, y times x plus 1, and on the left you have 2x plus 1. So 2x plus 1 divided by x plus 1 is y. 2x plus 1 divided by x plus 1 is y. So this is your inverse function. This is your inverse function. Now one more question. Now this is a very classic question. A lot of people mess up here. Okay. So let's say you have y equal to x square minus 4x plus 3. And the question is to find the inverse of this function. So how do you find it? Step number 1, swap x and y. So x equal to y square minus 4 times y plus 3. Step number 2, you have to make y as the subject. So what will I do? I'll shift x on the other side. So it becomes y square minus 4y plus 3 minus x equal to 0. Right? I shifted x towards the right, and instead of me writing 0 equal to y square minus 4y plus 3 minus x, instead of me writing it like that, I wrote it like this. Okay, I hope you understood. Now you have to make y as the subject. Can I say that we have a quadratic? In y? Where a is 1, b is minus 4, and c is 3 minus x. So how do you find y? How do you find y? Y will be equal to minus b plus or minus square root of b square minus 4ac divided by 2a, divided by 2a. So y will be equal to minus b, which means minus of minus 4 plus or minus square root of b square, so minus 4 negative 4 whole square minus 4 times a into c 3 minus x divided by 2a, divided by 2 times 1. Okay, so now let's solve it. This becomes 4 plus minus square root of 16 minus 4 times 3 minus x divided by 2. So 4 plus minus square root of 16 minus 12 plus 4x divided by 2. I have multiplied 4 inside by both the terms. Okay. So now what do you get? 4 plus or minus square root of 16 minus 12 is 4 plus 4x divided by 2. Now from both these terms you can take 4 common. From both these terms you can take 4 common. So it becomes square root of 4 times 1 plus x, square root of 4 times 1 plus x. Square root of a into b can be written as square root of a into square root of b. So this can be written as square root of 4 into square root of 1 plus x. Square root of 4 is 2. So 2 times root of 1 plus x. 2 times root of 1 plus x is the answer. So I'm writing it here. So this becomes 4 plus minus 2 times square root of 1 plus x. 2 times square root of 1 plus x divided by 2. Divided by 2. Now guys, if you observe, both the terms in the numerator are factors of the denominator 2. I mean, both the terms in the numerator can be divided by 2. So let's divide. So 2 times 1, 2 times 2, 2 times 1. So this becomes 2 plus minus square root of 1 plus x. 2 plus minus square root of 1 plus x. Now I have a very good question. By the way, this is f inverse of x. This is f inverse of x. My question is, does this function exist? Does this function exist, right? Because as per the definition of function, for a function to exist, every input, every value of x should have one and only one value of y. It should have one and only one value of output. For one value of input, you cannot have multiple values of output. For one value of input, you cannot have multiple values of the output, right? So can you say it's a function? So for all real values, if the domain is all real, then in that case, this is not a function. In that case, this is not a function. What I mean is, your function was y equal to x square minus 4x plus 3. If you graph it, let's say this is your y-axis, x-axis and origin. If you graph it, it will look something like this. If you draw a horizontal line anywhere on the graph, it is intersecting at 2 points. Which means the inverse doesn't exist. The way we have vertical line test for guessing if it's a function or not, we have horizontal line test to know if the inverse exists or not. So if the domain is all real, if you're talking about all the values of x, then for all values of x, for the all real domain, the inverse doesn't exist. But let's say I change my question. So I'm saying that my question is y equal to x square minus 4x plus 3, where x belongs to 2 to infinity, where I'm saying x is from 2 to infinity. Let's include 2, so let's use square bracket here, which means this time I'm talking about only this region. Okay, the reason being this point over here is 2 comma minus 1. This point over here is 2 and this point is minus 1. Okay, so I'm talking about only the right hand side half. I'm talking about only this part of the graph. I'm talking about only this part of the graph. So only in the yellow part, if you draw a horizontal line anywhere, it only has one point of intersection. So for this case, where I have restricted the domain, the inverse exists. And what will be the inverse? You can take a hint from here. What will be the inverse? F inverse of x will be 2 plus square root of 1 plus x. Okay. So like that, if you are restricting the domain, you can find the value of inverse of x. But for all real values, the domain doesn't exist. For example, we'll give you one more example. Let me erase this. Okay. Now let's say I'm talking about the left half. I'm talking about only this half. I'm talking about this half of the graph. Okay, I'm talking about the left half. So I'm talking about this part of the graph. Okay, so the question here is, you have a function y equal to x square minus 4x plus 3, but x belongs to minus infinity to 2. So the only blue half, the half part of the graph which is highlighted by blue color, so only the left half. In the left half, if you draw a straight line anywhere, it intersect at one and only one point. So again, for the left half, the inverse exists. So the inverse here will be y equal to, f inverse of x. Sorry, you can write y also, not a problem. F inverse of x will be equal to 2 minus square root of 1 plus x. Okay. So if the domain is restricted, you can find the value of inverse function. But for all real values, now instead of me highlighting just the left half, if I am saying for the whole graph, for this whole graph, what is the inverse function? Then for the whole graph, the inverse doesn't exist. You have two values, and you can't choose two values for one input, right? You can have multiple outputs for one input, right? So for all the entire graph, for the whole graph, the inverse doesn't exist. But if you restrict the domain, the inverse will exist. Very important concept. A lot of people forget this. I'm sure you must have understood this. In case you haven't understood it, please write down in the comment and I'll help you for sure. So I hope you enjoyed the video. So do like, do share, do subscribe. That's it for this video. Thank you.